Okay, let's give you guys some more practice. So here, show that this function here has only 1, 0 in this interval here. So our normal routine is to sketch this graph, is to sketch a graph of f of x. But in this case, it's a bit hard to sketch. So just jump to f prime of x, and then from f prime of x, analyze the f prime of x in order to show that this function here has only one and only one root within this region, within this interval here. Okay, so show that this here only has 1, 0 in this interval here. So press pause and have a go. Okay, so let's look at our function here. Our original function is this here. This is our original function here. Differentiate it. It will then give you this. Okay, so when you come to differentiate this, memorize this. When you want to differentiate 1 over x, it will give you this. So when you come to differentiate this here, visualize it as this thing here. So it's 1 over the bubble here. So when you want to differentiate 1 over something, it becomes minus 1 over the bubble squared. Well, the bubble is 1 minus x here squared. And then you've got to times with the derivative of the bubble itself. The derivative of the bubble itself, in this case, will be negative 1. Will be negative 1. See, this negative gets cancelled out with this negative, giving you positive here. Okay, well, anyway, differentiate this will then give you this. And memorize this. It will save you a lot of time. Okay, and then when you come to differentiate this here, memorize this as well here. It will save you a lot of time. So when you come to differentiate this, visualize as this. So you've got differentiate the square root of the bubble here. So when you differentiate the square root of a bubble, it becomes 1 over 2 root of the bubble, which happens to be 1 plus x here. And then you've got to times with the derivative of the bubble itself. In this case, it's 1. So when you come to differentiate this, it will give you this. Okay. Now analyze f prime of x. You see, let's analyze f prime of x. So this here is f prime of x, and we're trying to investigate it in this region here, in this interval here. Well, the point is that within this, so x can slide back and forth anywhere in between minus 1 and 1 here. X can slide back and forth, no matter where x is. This thing here, no matter where x is, the whole thing here will be positive, because let's look at this individually. So no matter where you put x, let's just choose x to be, let's say around here then. Let's say minus 0.999 here. Put that into here. Well, 1 minus a minus, that will be a positive. So this thing here will be a positive, and when you square it, it will give you a positive small number, and then 1 divided by a very small positive number. Then overall, this thing here will be a big positive number. Well, the point here is that this thing here, the whole thing here, will be a positive number, and no matter where you slide back and forth here, this thing here, when you look at this thing here, even if you choose positive 0.999 here, you put it into here, and 1 plus so when you put it into here, it will be 1.9999 here. The point is that even if you choose somewhere over here, negative 0.999 here, you put it into here, it will be the square root of 0.001. The point here is that this thing here will always be a positive number. So here you've got a positive number, no matter where you place x. This thing here will be positive. This thing here will be positive. Think about it. If you can't follow me, then actually press pause and think about this. But no matter where you choose x, this thing here will be positive, and this thing here will be positive, meaning within this interval here, f prime will always be positive. Now, if f prime is always positive, then that would imply that f, the normal function itself, will always be climbing. It must always be climbing. If the derivative is always positive, then it would imply that the original function itself must always be climbing. Okay, so we've established that f prime is always positive. So if f prime is always positive, it means that in this region here, the original function itself must always be climbing. So even if you start here, it must always be climbing. Even if you start somewhere around here, it must be climbing. Even if you start here, it must always be climbing. Well, here it must always be climbing. The point here is that if f prime of x is greater than 0, it would imply that the original function itself must always be increasing. So all we need to do here now is, well, if the original function itself is always increasing, then we just need to find a positive value here of the original function, and then another point where it's on the negative realm. Then it must cross over. Only one solution. Don't select one where this is positive and then this here is also positive, because it doesn't really tell us much. Select a point somewhere in the negative realm here, and then because you know that the function must always be climbing, then you know that there must be exactly one solution. So our aim here is to find out a point that's in the positive realm and then a point in the negative realm of the original function. So what we're going to do is select x to be, let's say, 0.999, and then select another point that would be negative 0.9999 here. So hopefully it would give us one value that's positive, and then over here it would give us a value that's negative. Well, anyway, here is our original function. Select a point here. So select somewhere here, 0.9999. So hang on. So f of 0.999 would give us, well, if you put this into here, it would give you that. Well, this thing here would be this. This thing here would be a very small number. Take away 5 here. Well, this thing here would be massive in comparison to these two. When you put 0.999 here, this thing here will be massive in comparison to this and this. So blah 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 blah. It would be overall, it will be a big positive number. Okay, so that means, looking at our graph here, it must be in a positive realm somewhere. Okay, so this is f of 0.999. So now we will select a point. Try to find f of negative 0.9999 here. So hang on. So now we need to find this. So hang on. So we are trying to find this here. Okay. So now put this into here. Okay. And then blah blah blah. Use the same argument here. So you've got this plus this. Take away this. This here is roughly a half. You see, this is like the number 2 here. So this is like near a half plus a tiny amount, and then take away a massive amount in comparison to these two here. So the point is that when x is negative 0.9999, this thing here will be a negative number. Okay, so overall your graph will look something like this. So here, well, it must always be climbing, therefore there can only be one solution. Okay.